welcome to Unbiased Science.
Where we bring scientific method to the madness.
We're your hosts, Dr. Jess Steyer
and Dr. Sarah Scheinman.
And this week we are joined again by the amazing Dr. Joe Schwarcz, who is going to talk to us a little bit about chemistry and food myths and misinformation in general and all the things that we're reading in headlines that are scaring the poop out of us to tell us whether or not we should actually be scared. So welcome, Dr. Joe, and thanks for joining us.
Well, thanks very much. Always fun and pleasure.
So real quick, before we get started, an update. We are recording this on November 12th, and the thing that people are buzzing about in public health right now is a major recall of infant formula. There have been 15 infants across 12 states that have developed botulism linked to By Heart infant formula. All were hospitalized. Thankfully, no deaths have occurred. Originally, a couple of specific lots were recalled, but the company made the decision to recall all of their formula nationwide. Just a quick note that infant botulism is fundamentally different from classic foodborne botulism in older children and adults. This is something that we absolutely should take very seriously. It could take up to 4 weeks for symptoms to show. So if your child is showing any of the symptoms, we've written about this at large on our page, and this is all over the news. But if your child is showing any symptoms, you should absolutely seek medical help. The last thing is that the good news is that this only represents about 1% of our formula supply here in the U.S., so this is not impacting or creating any shortages. But again, if your child has taken or has consumed any By Heart whole nutrition infant formula, those have all now been recalled. All right, let's turn to our special guest of the day. Sarah, would you like to read Dr. Joe's bio?
Absolutely. So, Dr. Joe Schwarcz holds a PhD in chemistry and is the director of McGill University's Office for Science and Society, which aims to separate sense from nonsense. I honestly wish more universities had an office like this. He is the recipient of numerous awards for teaching chemistry and interpreting science for the public. Dr. Joe has hosted a radio show on science for 43 years, appeared hundreds of times on television, and writes the Right Chemistry column for the Montreal Gazette. He has written many books, and his latest, Better Not Burn Your Toast, The Science of Food and Health, is a collection of bite-sized pop science essays unraveling the mysteries behind health-related science, from Ozempic to food dyes, aspartame to intermittent fasting. These fascinating insights are perfect for curious readers looking to better understand the science behind and inside our bodies. We are so excited to talk to you today, Dr. Joe, about your new book. Thanks for being with us.
Well, thanks a lot.
I was just going to start with the usual question that we've been starting off our episodes with, which was just like, what's a news headline or item that's caught your attention recently, health and science related?
Well, actually, there was one yesterday, pretty significant, about removing the black box warning from estrogen rules. And this comes from the FDA. And it was RFK Jr. who announced it. And as you may know, I'm not a fan of this gentleman. I think he has no business being Secretary of Health. He has no science background whatsoever. But, sometimes even a blind squirrel finds an acorn. And
I love that saying.
And, he's about as blind as can be. But anyway, in this case, this is correct. And of course, it doesn't really come from him. He just made the announcement. But it is correct because there has been this black box warning on estrogen products for over 20 years, based on some studies that really now are outdated, because there's been a lot of new information since that time. And also that original warning lumped all kinds of estrogen products together, including whether they were pills, systemic, or localized vaginal rings and vaginal creams, etc., which is a completely different story. I would not say that I'm an expert on vaginas, but I do read
This is already the best episode ever.
but I think I'm pretty good at reading and analyzing the scientific literature, and really the literature describes very well how minute amounts of estrogen are actually dispensed from the localized products, and there's no need for that black box warning about cardiovascular risk and cancer. And in fact, that warning has scared a lot of women away from using these products.
Mm-hmm.
And there's a lot of misery that can come with menopause, and estrogen can solve some of those problems. So I think in this case it was a move in the right direction. They've not made many moves in the right direction, but this is one of them.
Yeah.
And I will say, so Dr. Jen Gunter has done an amazing job covering this, and she has pointed out rightfully that there were some issues with the process through which this announcement was made. It sort of bypassed some of the usual channels, but to your point, Dr. Joe, absolutely, the overwhelming evidence does support this move.
Well, Jen,
so,
of
yeah.
course, Jen is excellent, and you can always bank on her coming through with her analyses, and yeah, I mean, I read her stuff; it's absolutely bang on. And
Yeah.
it's true that they didn't do the usual kind of consultation, getting together an expert panel and all of this. But nevertheless, I mean, in this case, I think they did arrive at the right result. So. It's
The acorn, right? I love it.
yeah,
Gotta give credit where credit is due.
yeah.
That's right.
And I mean, Kennedy also. He is against ultra processed foods, so I mean that is something, of course, we all agree on. Although he kind of presents this as if he were the discoverer of the problem, whereas of course the whole scientific community for decades has been advocating diets that are more plant-based and less processed. I mean, it's not that he discovered the problems with ultra-processed foods.
Right. Although I would say the approach that he and Maha has taken to ultra-processed foods, it's this blanket vilification where I would argue, if you eat occasionally, some ultra-processed foods, that is not going to kill you, right? As long as it's a part of a larger, diverse diet.
The whole approach that they're taking is I think is misleading, because it's really not the process that matters. It is the end result that matters. So whether or not a food is healthy or not should be determined by whatever studies are available about the nutrition qualities of that food, not how you arrived at it. Right? So there are certainly some foods that fall into the ultra-processed category by the usual definition that is now given, that it contains ingredients that normally are not found in the average kitchen, and that have multisyllabic chemical names, etc. Well, the fact is that, one of my favorite cereals, which is Fiber One. I mean, I'm not a spokesperson for Fiber One.
This is not a sponsored episode.
It's a very good cereal, but it would certainly fall into the ultra-processed category because it's got a large number of ingredients. But what I look at is the final sugar content, the final fat content, the final salt content, and the final fiber content. And all of those are in the right ballpark. So here's a very highly processed food that I have no trouble with. So it takes some careful analysis of what the composition of a food is, instead of looking at exactly what processing was involved.
Totally. And that's why, I have a bone to pick with those. There are apps now where people will, go to the grocery store and scan a label of a food, and it puts them immediately in a bucket of good or bad. And they often overlook the factors that you just pointed out, Joe. So it feels like an oversimplification.
Yeah, absolutely. I mean, nutrition is a very complicated science. And the truth is that there's a lot of very poor quality research in nutrition, right?
Right.
Because so much of it is based on food frequency questionnaires. And these are notoriously unreliable because people don't recall properly what they have eaten. they cannot recognize amounts. If you ask someone, well, you ate some pasta yesterday, how much did it weigh? And they throw up their arms because they have no idea of how to express that. And furthermore, these surveys show that people are not always honest because they will tick off the foods that they think they should have eaten instead of what they ate. And there's the classic example that according to these food frequency questionnaires, people eat more broccoli than the world is capable of producing.
Wow, how about that?
And also, the memory issue. If you're asked, how many avocados you ate within the last 6 months, it would be a total guess, right?
Yeah.
But one hopes that if you have enough data, enough such frequency questionnaires, that the errors kind of even out. But that probably isn't the case. So we have to be very circumspect about any of these nutrition studies that are based on food frequency questionnaires. And very often, it comes to just correlations and associations, which obviously cannot prove a cause and effect relationship. So nutrition is difficult to unravel. Yeah.
All right, so Joe, I need to know. So the title of your new book, "Better Not Burn Your Toast." What does that signify? What's the meaning behind it?
Well, the topic there is acrylamide, which is a chemical that forms whenever you have any kind of food that contains glucose and asparagine, which is an amino acid. Because when you heat these together, you will form acrylamide. Acrylamide is a carcinogen. Now that too is somewhat of a confusing term, because what it really means is that it is a substance that under some conditions, whether in the laboratory, on cells, or in animals, has been shown to have a carcinogenic potential. It does not mean that it causes cancer in humans. This is a very important point to understand because it is the distinction between hazard and risk. Hazard is an innate property of matter or of some process to cause harm. It does not take into account real life situation, whereas risk takes that into account. It takes into account numbers, takes into account exposure. So it is absolutely true that acrylamide as a hazard is a carcinogen, because you can point at studies where rats were treated with acrylamide in doses that are not achievable in the human diet, but they do cause cancer in the animal. So therefore, the International Agency for Research on Cancer, IARC, puts it in category 1, substance that is known to cause cancer. Okay? All right, so that frightens people. But the fact is that the amount of acrylamide that will form when you burn your toast is a very, very small amount. Now, there will be some, because your toast does contain glucose and it does contain some asparagine. So there will, in theory, be some acrylamide. What is the impact on that on health? Well, if we go by the amounts that are fed to animals, I would say it's minimal. But then people say, well, all right, what if you eat burnt toast every day for 20 years? It's a legitimate question. And we can't give a yes or no answer to that because, of course, nobody has studied that. Because what you would need are two groups of people that you follow, where the only difference between them is that one eats burnt toast every day, and the other group doesn't, and everything else is the same. They eat the same stuff, they have the same exercise regimens, etc. Obviously, this cannot be done. So we make an educated guess. That yes, that the amounts are so small that even if you eat it every day, it probably is not a problem. But it's still a better idea not to burn your toast. Why would you want to have any exposure to carcinogens, even if it is at a minute dose? So I think it's...
Not to mention the taste.
Yeah, well, it's a way of introducing people to the whole topic of how you analyze risk and what you make of hazard, etc. And of course, it makes for a good cover on the book because, as you well know, you can't judge a book by the cover, but you sell it by the cover.
Oh
Yes.
yeah, absolutely. I
Yes.
think we all judge books by their covers
Yeah.
Yes.
quite frequently.
And science needs better PR. People in science communication, we need to start thinking about it's not just the science, it's how we're telling the story, right?
Absolutely. And
Yeah.
the fact is that scientists, no, I'm not talking about science communicators, but
Hmm.
people who do the actual work, are
Right.
generally not very good at communicating what they do.
Mm-hmm.
And I have experience with this because I've interviewed many scientists, top-notch scientists, on the radio. And before the interview, of course, I always tell them, listen, we have an audience that's intelligent, but it's a lay audience. You have
Right.
to make sure that all the terms that you use, you define, because you can't assume that they know anything.
Right.
But the fact is that, when you're a researcher and you live your work 18 hours a day, you
Mm-hmm.
don't realize how specific your language is.
Hmm.
I mean, you can be a researcher, who works with RNA day in, day night. And you can't conceive that there's someone out there who doesn't know what RNA is. But
Right.
of course, most people don't. So even though you tell them, make sure that every time that you use a term, you explain what that is, it always slips in because they don't recognize the fact that they use these words all the time in their
Right.
language. So this is why I always say that science communication is a specialty, just like any other area of science, because
Mm-hmm.
you have to think about how you're going to do this. Not only what message you're going to get across, but how you get that message across. And the our opponents, the activists and the alarmists, are very good at what they do because they think about this, how to get your message, what examples to use. Like the environmental working group in Washington, they're very good at getting their message out because I'm sure they have focus groups. They
Yep.
Mm-hmm.
run it by them, and
They're
they know how
kicking
to
our
get the
butts.
message out.
Yeah.
Yeah.
Because, you know,
Yeah.
and uh, scientists don't think like that. I mean, research scientists. There
Right.
is a movement now, and I mean, in Canada, I think we have a very good thing now in that whenever you apply for a research grant, you have to put in a paragraph of lay language of how you would explain to a lay person what it is that you're going to do. I think this is a great idea
Fantastic.
because the fact is, if you can't explain to an intelligent layperson what it is that you're doing,
Right.
maybe you shouldn't be doing it.
Yep.
Because the goal of our research is to better society, right? You have to somehow contribute something. Now, it may be an indirect way,
Yep.
right? It's a long tunnel, but
Hmm.
there has to be a light at the end of the tunnel. So you
Yes.
have to be able to tell people what that light is, why you're doing what you're doing. Now, certainly there is an argument to be made for some fundamental or non-goal oriented research, just to learn, to find out. It's like
Hmm.
why do you climb Mount Everest, right? Because it's there, right? And you learn a lot about how to do it
Right.
and oxygen use and all of this along the way. Learn something. So there is an argument to be made for just such fundamental research. I think the argument is very often overplayed because such fundamental research rarely leads to something important. But of course, you never know at the beginning what will. I mean, classic example is MRI. I mean, back in 1940s, when Bloch and Purcell published an incomprehensible paper in chemical physics about the interaction of protons in magnetic fields, who could have ever guessed that that would eventually lead to MRI? I mean, they
Hmm.
would have never guessed. They knew nothing about medical uses. So there's an example of fundamental research, that eventually bore fruit. But that's the rare case.
Hmm.
So, I mean, most research really should focus on solving some sort of problem.
Right.
right? On a,
I mean, that's why when I was reading your bio, I kind of offhandedly mentioned I wish more universities would have what McGill has, this Office of
yeah,
Science and Society. It's something that I try and instill in my students when I'm teaching in the classroom. It's like when you're learning science, it's almost like you're learning a new language, but then you have to be able to then translate that language back into, words and ideas that anyone anywhere can
I mean,
understand.
science is difficult,
Right.
because it's not white or black.
Hmm.
It's many, many shades of gray. And just about any issue will have two sides, and very often you'll have experts on both sides. However, rarely uh, is the truth halfway in between. The truth is
Mm.
always closer to one side.
Right.
And that often doesn't get portrayed properly to the general public, because a reporter will, want to investigate some scientific story, be it climate change or whatever, and they'll go and interview an expert. But of course, journalism tells you that you have to present both sides, so they'll interview an expert on the other side. And very often it comes out as if those are equal sides, where
Right.
that rarely is the case. I mean, we know that 97% of scientists will agree that we have a problem with climate change, and
Mm.
that humans have a role to play there. But you will have some experts who will argue against that,
Hmm.
and generally argue very well.
Right.
They will have heard all the argument, and they know how to counter it.
That's such an interesting point, and I don't think that we talk enough about that. And I think it really confuses the public because we'll often get messages, how do I know who to trust? This person has a
Yeah,
PhD and they're
absolutely.
saying, and whatever. And it's very confusing, and that's difficult to, I don't know, that's a difficult thing to explain to a person sometimes, how to know who to trust.
Obviously, I mean, having a high degree is not a vaccine against stupidity.
Hmm.
I
Yep.
mean, and certainly it's not a vaccine against making mistakes, even legitimate mistakes.
Right,
It's
right.
not a vaccine against fraudulent science.
So, so Joe, I want to go back to one thing. And by the way, we have all these questions. We're not going to get through them. So
Yeah,
instead,
definitely not.
but I want to ask a more, I don't know, philosophical question. So we talked about burnt toast, right? In the title of your new book, and you distinguish between a hazard and a risk. And I feel like the U.S. and I don't know about Canada, we're really moving toward, especially with Maha's advocacy, toward this precautionary approach. So we talk about things like food dyes and aspartame and
Yeah.
things that I think, and please correct me if I'm mistaken, are hazards, right? We do have some, for example, animal studies, preclinical, in vitro studies that show that at extremely high exposure levels, these things could cause cancer. But we don't have the human data once we factor in how much we're typically exposed to, right?
Right.
But even with all of that, it feels like people are saying, well, why risk it? Let's just take the dyes out. Let's get rid of aspartame. Let's get rid of these things that we have any, even non-human data to support. What do you make of that? What do you think of
Well,
that?
of course, the cornerstone of toxicology was laid 500 years ago by Paracelsus, right? That only the dose makes the poison.
Right.
And, I mean, that applies to almost everything, but it does require a corollary. And the corollary is that dose sometimes can be very small.
Hmm.
And the example that you brought up before about botulism, right?
Yeah.
Well, I mean, botulin is probably the most toxic substance we know. Perfectly natural, of course, but uh, microgram quantities can be lethal.
Mm-hmm.
So sometimes that dose can be, infinitely small, and that's something that we have to admit when we talk about toxicology. And then, about the food dyes that you mentioned. Well, I think that the risk is absolutely minimal. On the other hand, I'm not a fan of food dyes because they are just cosmetic,
Mm-hmm.
right? They don't add anything nutritionally. But the real reason that I don't like them is because of the foods in which they appear.
Mm-hmm.
And what do you find? Where do you find these food dyes? You find them in Fruit Loops. You find them in candies, and it just isn't necessary. But I mean, toxicologically, I think the risk is very small. I mean, if you look at the red dye number 3 story, which was banned based on the Delaney clause, which doesn't make any sense because the Delaney clause it does not take risk into account. It's only hazard analysis. But I mean, when you take a look at the studies, the mice studies, there was no toxicity in mice, female or male. There was some toxicity in male rats fed huge doses. I mean, it just is a non-issue toxicologically.
One thing I'd noticed that I just want the public to understand. So let's say we do take these things out, they're probably going to be replaced with, natural colorings, and those have their own risks and their own allergens and their own, their storage considerations and things that could impact costs of food. Just certain practical things that I just sometimes push the public.
This is all true.
Right?
And this is kind of true across science, is that when you scratch the surface, it is always more complicated than it first seems.
Right. Right.
No matter what issue you look at, there's always more to it. And I mean, it's also for us, it's kind of fun because it becomes more and more interesting, right?
Right.
Deeper into,
as scientists, it is fun.
But it also becomes more confusing.
Right.
That's for sure.
Joe, I know Sarah was going to ask, we have a final question that we ask folks, but I just one last thing from me, and I know we're coming up on time here, but we talk about how the dose makes the poison, but the dose also makes the benefit, right? And sometimes people overstate the benefits of foods, and now we have this label like superfood, and there's a whole lot of marketing wrapped up here, right?
Absolutely.
So I think you've recently talked about like blue spirulina and this idea that olive oil is liquid gold.
Liquid gold.
Yeah. Just on the flip side, right? And any commentary on that and some of those bold claims?
Sure. Well, it is liquid gold for people who sell it.
Sure, absolutely.
But
what is a superfood? We hear this term thrown around a lot. I don't know what a superfood is.
There is no superfood. There are good diets and there are poor diets. And you can eat blueberries every day and still have a terrible diet. Or you can never eat blueberries and still have an excellent diet. You have to take into account everything that you eat, the amounts that you eat. There is just no magic. There are no magical foods. However, certainly we are learning that the more plant-based foods we eat, the healthier. I mean, this we know from a lot of epidemiological studies. Not just asking individuals, but you look at populations, and generally, I mean, we can say that people who eat the Mediterranean type diet generally are better off. And people who live on pizzas and hot dogs and hamburgers have more health problems. But whenever I'm asked to evaluate someone's diet, which happens, I say, look, the only way we can do that is for several weeks. You keep a food diary and you write down everything that you eat, and you do your best to estimate amounts. Get yourself a little scale and weigh, and then we can have a proper evaluation of what the diet is like. Well, I mean, health is much more complicated than just putting food into your mouth. I mean, it's obviously it is one very important factor because we literally are what we eat, right? I mean,
right.
Everything in our body originates from the food that we eat. So obviously there's a relationship, but there's also exercise habits. And you have to select your parents properly, right? Because genetics are...
Select your parents properly.
Yeah.
I love it.
It's a final takeaway from this episode.
Obviously, life is very complicated. But the thing is that people want simple solutions to complex problems. And that's what the activists and the alarmists are very good at doing. Yep. They will always have an answer, and it will be a clear-cut answer. Do this, don't do that. Whereas we in the science communication business have to pepper our language with ifs and buts and maybe.
Mm-hmm.
No one likes that.
No.
That's not so comforting to
Right.
people, right?
Right.
And it also it gives them the idea that scientists don't really know what they're doing because it's all ifs and buts. But that's what science is.
Totally.
But eventually we do arrive at some sort of consensus. So yes, we can recommend the Mediterranean type of diet because that's what the evidence builds to, and we're looking at a consensus. We're not looking at just one or two studies.
Sarah?
So we have a whole lot of topics that we didn't even touch today, Dr. Joe, but we do like this season. We've been asking all of our guests at the end of our episodes to talk to us a little bit about something in science or public health that's like giving you hope. That's kind of helping you to sleep at night because there's a lot of doom and gloom.
Yeah.
We've talked about a lot of difficult topics today, but what's something that's kind of giving you hope?
Several things. One is that the science communication business is expanding. There are more science communicators now than ever. I also get a lot of hope from my students. I have very large class. This term I have 1,100 in the class. It's a class on drugs, and so I get, of course, a lot of feedback, and they're very smart. They're good students, and they will go out and sing the message. I mean, I know that when I'm teaching them, it's basically talking to the choir, right? But the choir also goes out and sings elsewhere. So they go home, they talk to their parents, etc. So I see that works. I get a lot of positive feedback from our students. Now I know it's selective because we have the highest, the most stringent acceptance rate in Canada. I mean, our incoming class last year had an average of 92% from high school leaving. So yeah, I'm dealing with the cream of the crop. But that cream is very good, and it has been getting better and better. Students have been getting better and better. Of course, it's also because there's more of them out there, and so we're selecting, from the top. So that's good. And also, I see more and more skeptical articles being published, in various places.
Yeah.
But on the other hand, there's the TikTok and Instagram business, and some of it is very good, some of it is terrible, and it isn't obvious which are the good and which are the bad if you're not a critical thinker, or if you're not privy to how science works and scientific methodology.
Dr. Joe, we're going to get you on TikTok. We're going to get you on TikTok in 2026. That's my goal.
Yeah. So I tell you, I mean, so I see some positive things there, but I'm also convinced that we can't win the war, but we can win the odd battle. And I think that's what we have to target, because we are never going to have a population that is totally scientifically literate.
Right.
Mm-hmm.
We need much better science education in elementary schools and high schools. I mean, it really should be incomprehensible that someone should graduate from high school without having taken a course in chemistry, physics, and biology. That should never happen.
Hear, hear.
I mean, the same way that you study grammar or literature.
Right.
I mean, this is the language of science, and everything in life today is based on science. So
love it.
The same way that we expect students to learn spelling and learn the alphabet, you have to learn the alphabet of science as well.
Love it. Dr. Joe, you are just the best. Thank you so much for joining us. Everyone, go out and get a copy of Better Not Burn Your Toast, The Science of Food and Health. We will link to it in our show notes. Sarah, take us home.
All right. Thanks for joining us, everyone. Thanks for tuning in. We hope you learned a thing or two. Please join us next week on your trusted source for no nonsense, just science.